So what kind of suggesting is I've just loaded that first point PXY. If I want to move that in terms of sine, it's going to affect the cos. And it will affect the tan as well. For it to stay on that unit circle anyway. The first thing I want to mention to you is this thing I'm going to do in pink. I'm going to start referring to the quadrants by numbers. So when I refer to the quadrants by numbers, this is the standard. I've never seen it done any other way, which is good. So this top quadrant here is quadrant number 1. This quadrant over here to the left, but at the top, is quadrant number 2. This quadrant down the bottom, but to the left, is quadrant number 3. And this quadrant to the bottom and to the right is quadrant number 4. They're called quadrants, quadrant being the word that is used to describe a quarter in this case, so it's just that quarter of a circle or quarter of the Cartesian plane in each case. And you can see the 1, 2, 3, 4 link up really nicely with the idea that we start from the positive x-axis and we go around anti-clockwise. So we go through quadrant 1 first, then through quadrant 2, then through quadrant 3, and then through quadrant 4. So I will start just mentioning, this angle is in quadrant 3, and I need you to realise and understand what I'm saying. That's the first thing. What I'm going to show you now is that there are 4 angles, 4 theta angles, that are symmetrical, that are basically equivalent for each of sine, cos and tan. And we'll see, we might get down to the cast rule today, and I'll just probably leave it at that and let you play with that exercise or finish what you're doing. And then I'll go back through this again on Friday. So you get it 2 bites in it, because it is abstract, but it's really important. It's going to come up in a lot of the topics we do from now to the end of year 12. So you need to understand this symmetry. So there'll be 4 angles that are symmetrical, and they actually end up being the vertices of these rectangles. And those angles are symmetrical, which means they're equal, or they're negatively equal, I'll show you what I mean, in any case. There's one from each quadrant. So let me mark PXY there, and let me draw in light blue, because this is going to get really badly coloured. Light blue, that line, and the angle theta. That's our starting angle, and that's really important. And I'm going to go around and I'm going to just denote the angles. I'll do it in degrees and radians here. In fact, you can do it in degrees and radians. I'm going to do sine in degrees, because degrees is going to be easier for you to recognise. And then I'm going to do the cos one over here in radians. So I'll transfer it across to radians, and that way hopefully you'll get a good understanding, not having to worry about radians. So we have 0 degrees, and then up here we have 90 degrees, and over here we have 180 degrees, and then down here we have 270 degrees, and then at 0 we also have 360. And I could keep on going, but those are the 5 important ones. For those of you asking questions about negative angles earlier, 270 is the same as negative 90 degrees. And I can keep on working backwards in a negative direction, which is the clockwise direction. So I've got my angles on there now. Now, remember sine of theta is the height of this triangle. So hopefully you can see that the one other place in a unit circle where the height is going to be the same is over here in the second quadrant. So this will also be sine of theta, because that's a rectangle, so they match. You can just drag them across and see that happens. And that means if I draw this dotted line down, in fact I should change from purple, but I won't. That is theta as well, because that's sine of theta. And remember, we don't measure our angle though from our negative x-axis. We measure our angle from our positive x-axis around. So can anybody tell me what this angle is, but from the positive x-axis around to there? What is the value of that angle?
Theta plus 90.
Say it again, sir?
Theta plus 90.
No, but you're on the right track. So if I go 90, I get to there, but that's not theta. That's theta.
Okay. So 100.
Dylan? 135?
Yeah.
If theta is 45, yes, but theta is not definitely 45.
180 minus theta.
180 minus theta is what I was looking for, okay? So we don't know what theta is. Theta could be, I've drawn it so it's almost square. If it was a square, theta is 45, but it might be a really flat rectangle, and then theta might be 2 degrees. But this angle here, which I'll do in orange, around to here, this is going to get garish, is 180 minus theta. And what I'm actually going to do is I'm going to start naming the points on the unit circle by the angle they represent. So when I say that, and I'll do this in green the whole way around, that point there is theta. And this point here is 180 minus theta. And we have just built an understanding that, in fact, we've built this understanding. Sine theta is equal to sine pi minus theta. Pi is 180, yeah? That's the first understanding we've built. Now let me track down here. Can anybody tell me and label that angle in green? Third quadrant angle. Down here, what will that be? This one with 180 minus theta? What's this one? Are you going to say the same thing?
No. Is that correct?
Go for it. 180 plus theta. Okay? So that angle down there, we have, because remember it is a rectangle, so we've got this symmetry, and that's what this whole thing's about, symmetry. That, let's go back to purple here, that's theta. And so this one in green is 180 plus theta. But is sine theta the same down here? Is that distance the same as that distance?
Yes, just negative.
Yes, it is. So it's the same distance, but the displacement it's in a negative direction, yeah? So actually what we get is this new relationship down here. Sine theta is equal to sine of pi minus theta in the second quadrant. In the third quadrant, no, it is equal to sine of pi plus theta, but it's negative of that because this is a negative displacement. It's in the negative y-axis. Does anybody have any questions so far on that? We're going to get 4. If you understand the third, the fourth one's trivial. So that's 180 plus theta. And over here, can anybody describe what this angle could be called? Somebody different who hasn't answered the question so far. Out. That fourth quadrant angle? 360 minus theta, perfect. That's the norm. Again, this is the norm, but it could be called something else.
Could you just call it negative theta?
You could call it negative theta, but that's the norm. That's what you'll see in your textbook. That's what you'll see in most examples. You'll see this more commonly, but you could use negative theta. And so just understand 360 minus theta, negative theta, the difference is 360, which is a full rotation. So that difference is allowed. We could just take that full rotation out. So it's all good. And that's obviously got a negative displacement again. So that's there. This is negative sine theta, and this one is negative sine theta. And so we get our fourth relationship down here. Actually, what we get is that sine of theta is positive. Sine of 180 minus theta is also positive. Sine of 180 plus theta is negative, but the same as the other two. And sine of 360 minus theta is negative, but the same as the other two up here as well. And these two are exactly equal, which might come in handy at some point. There's your relationships. Now, this is mapped out in your textbook. There's a table with all of these relationships. There's heaps of them. And I don't expect ever that you will go towards memorising all these relationships. Some of you will try, but it's very easy to mix them up. If you have a good understanding of the unit circle, you will be able to get every one of these relationships just by drawing a simple diagram. Just keep that in mind. As long as you know sine theta is the vertical and cos theta is the horizontal, it won't be a problem. So, but I would say for now, while you're doing questions, don't try and memorise them. Just have the table next to you. Just use the table. And then start to practice trying to do it without the table by drawing a unit circle. And I'll show you those examples. Now, I think we're mostly up to date. I'm going to scoot sideways a little bit and just start working on the cos one. And I'll try and make my cos diagram less intense, shall I say. How about that? So we've got the same things. This time I'm going to do it in terms of radians. So I've got 0 radians. I've got pi on 2 radians. I've got pi radians, and I've got 3 pi on 2 radians. And then over here, this is also 2 pi radians, 4 pi on 2. That's also negative pi on 2 radians if you want to, etc. This point here is theta, and it gives me that angle theta. This point here is 180 minus theta, and it gives me this. And this point down here is 100, I didn't want to use 180, do I? I want to use pi. So pi plus theta, and this point over here is 2 pi minus theta. There are 4 angles in the unit circle for those on the rectangle vertices for those symmetrical angles. Now in this case though, we're measuring cos theta. So here's my cos and cos, but in this case cos is the horizontal displacement. So now I need to ask you, which quadrant is equivalent to cos theta? Hands up if you know. So there's 4 quadrants, do you know? Quadrant 1 is cos theta, and there's another quadrant that's equivalent to it. This is quadrant 1.
Quadrant 2.
Not in this case.
Quadrant 4.
Quadrant 4, because it's quadrant 1 and 4 that have the positive horizontal displacement. Positive, sorry, let me try that word again. Positive and quadrant at the same time doesn't work. Quadrant 2 and 3 have a negative displacement horizontally. Can you see that? But actually this distance is going to be the same as that distance because we have all the symmetry happening in that rectangle. So this is equal to cos theta, but it's actually equal to negative cos theta. It's a negative cos theta displacement because cos theta is that horizontal component. So now we've got a slightly different relationship, almost exactly the same. Cos theta is equal to negative cos of pi minus theta, which is equal to negative cos of pi plus theta, which is equal to cos of 2 pi minus theta. So quadrant 2 and 3 are negative, quadrant 1 and 4 are positive. Magic. I'm going to take you to the cast rule. I'm going to teach you how you can memorise this using the word cast, basically. So that's it. It's like Sokotoa or foil, those other mnemonics that you've learnt before. This cast is going to be the magic word for this one. That will really help you, but that's cos. Does anyone have any questions at the moment? So I'm getting a little bit quicker. I'll give people a chance just to write this down, and then I'm going to talk about tan, and then I'm going to introduce you to the cast rule, and then you can either go back to carrying on with what you're doing, or you can have a crack at 15E. But I mean, I haven't really gone through any examples, but I also don't want to stand here and talk at you for 50 minutes. So have a crack at it. On Friday, I'll reiterate, and then I'll do some examples. That'll be the plan. Okay, here's our third one, tan. I've already got the relationships down there. And you can see the relationships are slightly different. This time, tan is equal to sine over cos. So we have our same values, and I'll stick with radians. So we have theta, pi minus theta, because this is pi, and we have pi plus theta, and we have 2 pi minus theta. There. Now, tan of theta is positive. Tan of any number between 0 and 90 is positive. Tan of pi minus theta is in the second quadrant. What's our tan relationship? Sine over cos. Is sine positive or negative in the second quadrant? Sine is the vertical, and the vertical is positive. Is cos positive or negative?
Negative.
Negative, because it's in the negative axis. What's a positive divided by a negative? A negative, thanks. Positive divided by a negative is a negative. Tan of theta is the same as tan of pi minus theta, but it's negative. So we're getting that relationship again. This is just harder to touch and feel. Tan of theta is nothing special on this diagram. The textbook has a crack at extending the triangle outside the unit circle and showing you what tan of theta could be. I've decided not to go there. You're welcome to read it if you want. Just relate it to sine and cos. Third quadrant. Is sine positive or negative in the third quadrant? Negative, because it's below the x-axis. Is cos positive or negative? Negative, because it's on that side of the y-axis. What's a negative divided by a negative? Positive. Third quadrant, tan is positive. Fourth quadrant, sine positive or negative? Negative, it's below the x-axis. Cos positive or negative? Positive. What's a negative divided by a positive? A negative. So they're all equal, and you can test this if you want with an angle. In fact, I'll get you to do it in a second, except the second quadrant and the fourth quadrant will be negative. So, and we get this relationship. So I'm going to write that. I'm going to say leads to this from tan theta is equal to sine theta over cos theta. And we just check those negatives and positives. And here's my summary for the cast diagram. If you draw a unit circle, And you probably won't do this for a cast diagram. You'll probably just draw your axes. That's bad. Let's try that again. This is the one major downside of the video, is that I can't remove it so easily. So in this one, in quadrant 1, which of them are positive? Tan, sine, cos? All of them. So we call this the A quadrant because they're all positive. In quadrant 2, which ones were positive? Just sine, because it was a positive vertical, but a negative horizontal, and a positive divided by a negative made a negative for tan. So just sine. Which one was positive in the third quadrant? Just tan, because cos and sine are both, cos is negative, sine is negative, but negative divided by negative is positive. And in the last one? Cos. That's going to be massively important, that you remember that if you are calculating cos of an angle that's between 270 and 360, it will give you a positive value, but sine of that angle and tan of that angle will be negative. Let's have a look at a particular angle, just as my last little discussion point. Finally, a couple minutes of your time. Can somebody pick an angle between 0 and 90? 37, let's do it. Can somebody tell me what sine of 37 degrees is?
Negative 37.
It can't be negative. We've just decided that sine is positive in the first quadrant. Don't do this to me. Just check you're in degrees, not radians. 0.62?
No, 0.6.
Okay, let's go 0.6. And what's cos of 37? 0.4. Is it? Has anybody checked that? Because I've got a feeling Baxter's was making it up.
To be fair, that was mental math.
0.79. 0.8.
Wow.
Two decimals.
I see why you made that. You went 1 minus, and that makes perfect sense. I'm actually going to lead you in a minute, well, not a minute. In a couple of lessons, we'll start talking about there's a special Pythagorean relationship. If this is sine, and that is cos squared plus sine squared must equal 1. We'll talk about that more because that's a right angle triangle. And 6 squared plus 8 squared is 100, so you get 10. So this 0.6 and 0.8 gives you 1. So it's not a minus relationship, it's actually a Pythagorean relationship. Tan of 37, let me guess, it's going to be 0.6 over 0.8, so about 0.75? Okay. So these are all approximate angles. And if I go along here now, can anybody tell me what sine of 37 is in the second quadrant? What's the angle, first of all? What's that 37 angle? This angle here. 143. If anybody doesn't know how we got that, and by we I mean Baxter, maybe somebody else called it out as well, we just did 180 minus 37. 180 minus 37 to give us the equivalent angle in the second quadrant. Get on your calculators now and check. Sine 37 should be positive 0.6, cos 37 should be negative 0.8, and tan 37 should be negative 0.75. You should get the same numbers, but that negative positive relationship should hold. Check that happens. Down here I've got this. 180 plus 37, which is 217. And over here I've got 323. And so we should get relationships like sine of 37 should be equal to sine of 143, this is all in degrees, which should be equal to negative sine of 217, which should be equal to negative sine of 323. Check it if you like, but I promise you that as long as you are in degrees, that is definitely true. The same thing will hold with cos, except cos will be positive here and negative in the middle too, and the same will hold with tan, except tan will be positive there and it's negative there and there. And that'll be true for every angle. And actually it turns out it's true beyond the first, the 0 to 90 range, if we have theta as 110, but we don't really need to worry about that too much. Any questions? So the exercise 15E, which you can have a go at if you want to, is going to basically give you, a lot of it is giving you these values and asking you, it might say, given that sine 37 equals 0.6, calculate the value of sine 217. Now, it's not going to ask you that unless 217 is a special angle to 37, i.e. it's one of these other three. Otherwise, you can't do it. So just keep that in mind. They're fairly easy two-line questions at most, but they do rely on this knowledge. Otherwise, finish exercise 15A to 15D. They're your two options. And I'm going to go through this again on Friday and reiterate the whole thing. That's the plan. Thanks.
Whoa.